I welcome you all for today's session. In this class, we are going to learn about the element resistor. So, resistor is a passive element. So, we all know what is a passive element. The element is not able to supply power to the any other element in the circuit, then that element is said to be passive. So, resistor is not able to supply power to any other circuit. That's why resistor is a passive element. Okay, so this is the symbol for a resistor. So R will be resistor will be represented with this symbol. Okay, so this is the resistor. So the resistance of this resistor is R. Okay, I am naming, generally we represent resistance with symbol capital R. Okay, see, for example, I have applied a voltage V across this resistor, then there will be current passing through it, let it be I. Okay, so if I want to know what is the value of resistance R, this can be given by V divided by I. This is from Ohm's law. So first we have to know what Ohm's law states. So according to Ohm's law, at constant temperature, the voltage across any conductor is directly proportional to the current flowing through it. Otherwise, I can define this Ohm's law in another way. The current flowing through any element is directly proportional to voltage applied across it. Now we'll see what are the units for resistance. See, all of you, here resistor is an element. Resistance is the property of that element to oppose the free flow of electrons. So the units for resistance is, I can represent with volts per ampere, or in general we will represent with ohms. So the units for resistance is ohms. Okay, now for this element R or the resistor R, if I want to draw the VI curve, means characteristics between voltage and current. So I am taking voltage on x-axis. I would like to find I in terms of, see, for example, for instance, I am taking R as 10 ohms. See, if R is 10, I is equal to V by R. Let us assume that initially voltage applied is 0. If V is 0, V by R is 0. So this current is also 0. If V is 5 volts, means the applied voltage is 5 volts, then this will become 5 divided by 10. So this will be 0.5 ampere. So if V is 10, it will become 1 ampere. If V is 15, so 15 by 10, 1.5 ampere. If V is 20, I becomes 2 ampere. So if I take V on x-axis and I on y-axis, if I draw a curve by joining all these points, see, at V is equal to 0, I is what? 0. This is the point. When V is equal to 5 volts, I is equal to 1 ampere. Let it be, see, 0.5 ampere. Let this point be 0.5 ampere. Then that point will come here. If I is 10, sorry, if V is 10, then I is 1 ampere. This is the point. So if I join all these points, then I'll get a straight line like this. Okay. So even if I take negative, for example, minus 5, then it will become minus 0.5. I'll get a curved straight line like this also. In the negative, if I change the polarity of voltage, and if I draw the characteristic curve between voltage and current, then I'll get the curve like this. So it is a straight line passing through origin for all time t. So that's why it is a linear element also. So resistor is a linear element also. Already I told you in the previous classes, the characteristics of a linear element will be a single straight line passing through origin. So here also we are getting a single straight line equation passing through origin. That's why resistor can be said as a linear element. Okay. Okay. Now let us go further. Please wait. Okay. Now, for example, I want to know what is the power. This power is given by P is equal to V multiplied by I. See, in place of this I can write V by R. So that's why V into V square by R. This is another formula to find the power. See, again I can write in place of V I into R. So if I substitute I into R, I'll get I square R. This is another way of representing power in the circuit. Okay. Please. See, conductance is, see, for example, I want to know what is conductance. Generally, it is the inverse of resistance. Means resistance is opposition to the flow of electrons. Conductance is allowing free flow of electrons. That's why I'm getting Z is equal to 1 by R. So it is inverse of resistance. Okay. Let me go further. So generally, the conductance also represented with the same symbol. So this is the symbol for conductance. So here also if I apply a voltage V, then there will be current flowing through the conductance. So units are ampere for volts, or Siemens, okay, or mhos. Okay. Now let me go further. See, if I am taking a short circuit means if two terminals are joined with a single wire. So for example, these two terminals are joined with a wire, then these are said to be short circuited. So short circuit, the resistance will be 0, means there is no opposition for the flow of current if it is a short circuit. So if resistance is 0, then I into 0 becomes 0, means in case of short circuit, the voltage is 0. The voltage across short circuit is 0. Means, see, even when the applied voltage is 0, we are getting a huge current flowing through the circuit. Means at no voltage, even though voltage is 0, see if I bring this 0 this side, V by 0 becomes I, 1 by 0, anything by 0 becomes infinite, means there is huge current flowing even though voltage is 0 in case of short circuit. Next one is open circuit. See, in case of open circuit, there will not be any current flow. Why? Because there is no path for the current to flow from here to here. So in case of open circuit, see, current is not flowing means it is completely blocking the flow of current, means very high resistance. That's why we are getting R is equal to infinite. The resistance is infinite in case of open circuit. See, whatever the applied voltage V will be appear across these two terminals. So V will be there, but I becomes 0. Why? Because this R is infinite. Okay, that's why I see here, even though I am applying a voltage very huge, there is no current flowing through that open circuit. Okay, so current is 0 in the open circuit. So let us now see elements connected in series. For example, I have n resistors connected in series. So when elements are connected in series, they will carry the same current. See here, I have applied a voltage source Vs in this circuit and the resistors R1, R2, so on. I have n resistors Rn. All these are connected in series. If those elements are connected in series, this Is coming out of the source must be flows through all these elements. Why? Because it has only one path. It has to go like this and it has to move in this direction. It has to flows through R1, R2 and so on up to Rn, and again it completes its paths like this. So all these elements are connected in series, so they are carrying same current Is. So now if I apply KVL for this loop, see, for example, I am applying KVL in this loop. Then see, according to our convention, what we are following is we are starting with the negative terminal of the source. So minus Vs plus the current flowing through this I am assuming as Is. Okay. So what is the voltage across R1? That is V1. Otherwise, let me write minus plus V1 plus V2 plus so on plus Vn is equal to 0. Okay. Now I want to write this all these things in terms of Ohm's law by using Ohm's law. See, this V1 can be written as Is multiplied by R. Is is the current flowing through the resistance R1 multiplied by that resistance R1 gives you voltage across that element. So Vs is equal to V1 plus V2 plus V3 plus so on plus Vn. So Vs is equal to V1 can be written as Is into R1. Similarly, V2 can be written as Is into R2 plus so on Is into Rn. See, in all these terms, Is is common. So I can make Is common. I'll get Vs is equal to Is into R1 plus R2 plus R3 plus so on plus Rn. Okay. So let me erase. So like that we got this one. So Vs is equal to V1 plus V2 plus V3 plus so on Vn. So by applying Ohm's law, I am getting this. See, in this, I am making Is common. Why? Because Is is there in all the terms. So Vs becomes Is into R1 plus R2 plus R3 plus so on Rn. So if I bring this Is left side, what I'll get? Vs by Is is equal to R1 plus R2 plus R3 plus so on Rn. So what is this Vs by Is? Nothing but equivalent resistance. Again, V by I is R according to Ohm's law. So R equivalent is equal to R1 plus R2 plus R3 plus so on Rn. Means if I have n resistors connected in series, if I want to replace all these n resistors with a single equivalent resistance, then I can replace with a resistor having resistance which is equal to R1 plus R2 plus R3 plus so on Rn. Means how many elements are there with me? If I add resistances of all the elements, I'll get one resistance. So if I have a resistor having that resistance, I can replace all this series combination with a single resistor having that resistance value. So now let us see elements when elements are connected in parallel. Before going to that, when the elements are connected in series, see the voltage Vs is divided into V1 plus V2 plus V3 plus so on Vn. So when elements are connected in series, voltage division takes place. So let us see how the voltage division rule can be applied. See, I replaced all the series combination of resistors with a single resistor having resistance is equal to R equivalent. Okay. So now we'll see voltage division principle. See, if I want to find voltage across any element in the series combination, for example, for instance, I want to find the voltage across the resistor Rn in the series combination. So voltage across the element Rn is Vn is equal to total voltage applied across the circuit is Vs multiplied by the element in which I want to find the voltage, that is Rn. So Vs multiplied by resistance of that element divided by total equivalent resistance of the series combination gives you voltage across that particular element. See, for example, if I want to find voltage across the first element V1, so then V1 according to voltage division rule, V1 is nothing but Vs into, in which element we want to find the voltage? First element, that is R1 divided by R equivalent. Likewise, if I want to find voltage across resistor R2, then total voltage Vs into R2 divided by R equivalent. So, like this, in series combination, whatever the voltage across any element, if you want to find, you can find. Okay, I would like to stop here for today.